All right, so we're going to do two more of those point of concurrency. What does that mean, point of concurrency? It basically means, well, let me make this so I can write on it. So watch. If I had a line goes here, a line goes here, and a line goes right there, okay? What is that point right there? This is the point of what? I just said it a couple times. The point of concurrency. Okay, that's the phrase that I'm going to be using. So you need to understand what it means. When you have two or more, okay, in this case it's a triangle, so you're going to have three. All right, so when you have three lines that intersect each other at the same point, okay, at the same exact point, we call that point the point of what? Concurrency. That's a very general term. All right, let's go through quickly. We already did it before I started recording, but let's do it one more time. Okay, so if I have a triangle, let me try to write that a little bit better. If I have a triangle, and I was able to draw the perpendicular bisectors of each side of the triangle, what did I just find? What do we call that particular point of concurrency? It's called the circumcenter. Very good. So I'm just making my little list here, all right? So we've done two already. We're going to do two more today. Guess what the two are called that we're going to do today? Take a wild guess. Very good. Incenter and centroid. You got it. All right. So now, what if you took a triangle and you drew the altitudes? What is the altitude? It goes from a vertex perpendicular to the opposite side. If you draw an altitude, all three altitudes, it's all going to meet at one point, which means it has a point of concurrency. All right, so they're all going to meet at one point. What do we call that? I guess I could finish writing that out, couldn't I? What do we call, the point of concurrency when you draw the altitudes? It's the orthocenter. Okay? So now, what we're going to do, at the end of this, we're going to have a 3, and we're going to have a 4, and this is going to go to what? Incenter. And this one is going to go to centroid. Problem is, I don't know what you do to the triangle to get the incenter. I don't know what we do to get to the centroid, but that's what we're going to learn today. Does that make sense? All right, let me just... Okay. All right, let's move on. So now let's talk about incenter. This is the third one. Okay, there's 4 of them all together. This is the third one, and it's called the incenter. So how do I find the incenter of a triangle? Well, let's draw a triangle. I tell you what, before we even do the triangle, let's do this. Take it about right there. Let's just do an angle right now. Let's just talk about one angle. All right. So I got an angle. All right. This is going to lead you up to the triangles. Okay. This is the one thing we need to know in order to lead you up to what we're going to talk about. Let's do this next part in a different color. Now watch what I'm going to do. I'm going to take that angle and I'm going to split that angle into 2 equal angles. All right. Do you think that split it right there? No, it's a little too close to here, okay? If I split it, I want to be where? Kind of about in the middle, right? I want to split it right down the middle. All right, does that look about down the middle? Close enough. I'm just eyeballing it. All right. All right, so I split that so that this angle equals this angle. Here's a word that we talked about earlier. We've talked about that word today. We've talked about the last couple days. If I split something in the middle, what am I doing to it? What's a good geometry word that we've talked about before? Now, splitting in the middle doesn't mean necessarily mean just intersect, because I could intersect this thing anywhere and it doesn't split it in the middle. What specifically am I doing to something? I did it to a line segment earlier when I did circumcenter. If I split something in the middle, this splits this whole angle into two equal angles. What did I do to it? Nope. Well, you kind of used one of the words, but it bisects it. That's right. It bisects it. Bi meaning what? Two. Bicycle. Two wheels, right? Bicycle. So bi meaning two parts. So this ray right here, that red one, what did it do? It split it into two equal angles. So what do you think? I named that red one right there. That's a what? It's a bisector. And we bisected a what? We specifically bisected an what? An angle. So what do you think we're going to call it? An angle bisector. All right, so that red line right there, it's not a line, it's a ray, because it starts at the vertex and it keeps on going. All right, so that ray is considered an angle bisector. All right, what about this line? What if I drew that line? Is that an angle bisector? That blue one? Right, it doesn't go down the middle, does it? All right, look, it makes a little tiny angle here and then a huge angle right here. You follow me? So this blue one, is that an angle bisector? No. Just because it goes through the angle somewhere doesn't mean it's a bisector. What makes it a bisector? That these two angles are what? Are equal to each other, okay? So you first got to know what an angle bisector is. Everybody got that? Okay, so now let's do a triangle. So let's put a triangle in here. I'll just do kind of the same looking triangle that we've always been doing, just a nice acute triangle. And what do you think? Take a wild guess. Shouldn't be a wild guess because we just talked about it. Okay, an educated guess on what we're going to do with each of these angles in this triangle. We're going to bisect the angles. Exactly right, okay? Now, I'm going to have to eyeball it because I don't have like a protractor or anything to figure out exactly what halfway is. So I'm just going to have to eyeball it, but we'll try our best. All right? So do you think that bisects the angle? Do you think that bisects the angle? Nah, so I would say somewhere in there, don't you think? I'm going to take it all the way to the other side. But what am I looking at? I'm looking right here and right here to see if they look the same. Everybody see that? I don't care where it hits over here. I'm not trying to bisect that side, am I? All right? All I'm doing is looking at this one and this one to see if they're equal to each other. Do they look equal to each other? Yeah, pretty close, okay? Just eyeballing it, right? It looks pretty equal. So let's do another one. We'll do a different color just to mix it up. So let's do this angle up here. Again, I'm going to bisect it. Do you think that bisected it right there? No. Do you think that bisected it? No. So again, I'm looking here. You see right here? I'm looking to see if this angle and this angle are the same. I don't care where it hits on the other side of the triangle. I'm just trying to bisect that angle. So does that look about right? Yeah, it looks pretty close. Again, what am I trying to do when I bisect it? I'm trying to see if this one and this one are equal. We got it? Now, just because these have one arcs and these have one arcs, does it mean that all those little angles are the same? No. Technically, I should put two arcs there, but since it's in a different color, I'm just going to do one. Is that all right? Okay. Let's do another one in another color. Let's go yellow, like that one. So now, what do you think we're going to do to this angle down here? Bisect that angle. That's right. And guess what's going to happen? It's actually going to go, now, again, I was eyeballing it, so it doesn't look quite exact. But if I was to get it, if I was to find exact angles, it looks just a little bit off. But if that angle was equal to that angle, guess where they would hit? Right there. It's a point of what? Point of concurrency, because all those lines intersect at one point. Take a wild guess. It's not wild again. take a guess what we're going to call that. The point itself. The point itself. Look, I couldn't make it easier for you. It's right there on the screen. I scrolled it down so you can see it. It's the incenter. That's right. That's what we just found. So this point right here, let's go a different color. This point right there is called the what? The incenter. How did we find the incenter? What'd you do to find the incenter? The angle bisectors. That's right. You found the angle bisectors in that triangle, and that gives you the incenter. Remember that little list we were making at the very beginning? Let's go back to that. See this? Put a little circle there. So how do we find the incenter? We find the what? The angle bisectors. Everybody see that? So these are 3 things, 4 by the end of class, all right? But 3 things so far that we need to know. How did you find the circumcenter? Found the perpendicular bisectors. How do you find the orthocenter? Find the altitudes of the triangle. How do you find the incenter? You find the what? Angle bisectors. Okay? That's something you're going to have to know on the quiz and the test. Everybody got that, right? All right, so don't get that quiz and test. You're like, oh, I don't know. I have no idea. Okay? If you look at it for 5 minutes, 2 minutes, before you come in and take the quiz and the test, you should be able to get these right. That's all it takes. But don't do it just 2 minutes before the test. Look at your notes every night and go through it. I have a hard time remembering these from time to time because I only teach it once a year. You know, by the time the next year rolls around, sometimes I forget which one goes with what. All right? But you got to remember it. This is going to be on the test. All right. So, I shouldn't have made these all different colors. Let's make these all red because of what I'm going to do right now. Red. There we go. And we'll get rid of all this mess. Just clean it up a little bit. Zion, you had a question? Dude, I thought you had like a good math question. We'll keep that yellow in there. Getting to the good part, you're going to miss it. That was quick. Thanks. All right. So, here's what... Do you remember with the circumcenter? The circumcenter was equidistant from all 3 vertices. Do you remember that thing? Remember we found the circumcenter, we drew those lines. I think we always made them yellow. All right, it was equidistant from the 3 vertices. Orthocenter. What was special about the orthocenter? Nothing. There was nothing special about it. Remember I made a big deal about that? There's nothing special about the orthocenter. All right. Now, we find the orthocenter by finding the altitudes, but really, where the orthocenter is, there's really nothing special about it. There is something special about the incenter. Now, watch very carefully. Let's go yellow. We've been using yellow to do these. What's special thing about it? Now, check this out. This is kind of cool. If I took the distance, not from the point to the vertex, but if I took the distance from here to the sides, they're all going to be the same. So this is the exact same distance from this side as it is from this side as it is to this side. Now, what do I mean the distance? Like, what is the distance from here to here? Is that the distance? Is that the distance? Is that the distance? Where do you think the distance is? It's perpendicular. So that, see that distance right there? See that yellow? If I draw a line perpendicular to this side, and then I draw a line, I'm going to have to eyeball this. That kind of looks about right. That looks perpendicular. Oops, come on, let's get rid of that. There we go. And then, now again, this may not be exact just because I eyeballed it, but I will tell you what's equal and what's not equal. See those three lines right there? If I would have drawn that incenter exactly perfect, all three of these yellow lines would be equal to each other. So that would be equal to that, would be equal to that. That one looks a little bit longer because I wasn't super accurate, okay, on finding the incenter. But if I was very accurate on finding the incenter, then those three yellow ones would be equal to each other, all right? So we say the distance to each side would be exactly the same. It's equidistant from the sides of the triangle. You see that? So how did we find the incenter? What did we do? No. How did we find the incenter? It's right there. We found the angle bisectors, didn't we? I bisected this angle, I bisected this one, and I bisected this one. And they all met at that one point. That one point is called the incenter. Now, what's true? What's special? What's unique about that incenter? Okay, that incenter is the same distance to each of the sides of the triangle. It's equidistant from the sides of the triangle. Let's write that down. Equidistant, okay, from, or to, I guess you could say, the sides of the triangle. Okay, equidistant, meaning the same distance. Meaning, watch, what if I told you that that little length right there is 5? What would this little length right here be? 5. What would this length right here be? It'd be 5. It's as easy as that. Okay, so if you have an incenter right there, if you have an incenter, the distance to the sides. And what is the distance from a point to a side? It's the perpendicular distance. From here to here, here to here, here to here, they're all going to be the same. And that's super important. Because you're going to have questions on the quiz and the test where I tell you that this is the incenter, and then I give you one of these sides, and you're going to have to find the other two. And that's super easy because they're all the same, right? So if this is 5, then so is this one and this one. All right. I'll tell you what. Oh, we got till 10 till, don't we? The other class. All right, I can do this next part. I was thinking we only had 5 minutes, but we got 10 minutes. So let's talk about another word. There's a lot of words in here that we're talking about, but let's talk about this word right here. I tell you what, I don't want to try to fit it in 10 minutes. I don't think I have enough time to really make it the way I want. So let me take a look at what your homework is, and I'm going to revise the homework just a little bit. So incenter centroid, I told you to do 1 to 12. Let me look in the book, because I don't think you'll be able to do 1 to 12. So let me find the ones that you should be able to do. Well, actually, they kind of throw them all in there. Well, actually, I think you can. I think you should be able to do 1 through 7. Okay? So I'm going to revise this homework a little bit. Let's do 1 through 7. All right? So we're going to call it section 5.2. Call it A. All right? And I'm only going to give you 1 through 7. If you look in the lesson plan that I gave you, I say 1 through 12. Because I was thinking that I'd be able to finish this lesson in one class period, but I really do think that I need to save that. I think I have tomorrow for you working on homework in class anyway, so it works out perfect. so I can teach you the second part of 5-2 tomorrow. So this is what's due tomorrow. Even it's a little different than what the homework says, all right? But 1 through 7, you should be able to do all of those problems today, all right? So that will be due tomorrow. Tell you what, I'm gonna shut down the video, but I'm gonna go through at least the first little sets of problems, okay? Just to kind of get you going on it a little bit. We got some time, so let's not waste our time. Let's use it. But I'm gonna stop the video now.